Problem 90. We are trying to evaluate this series. It's in summation notation, and we want to figure out if it's arithmetic or geometric. First of all, we can figure out arithmetic or geometric a couple different ways. I could just start substituting values in, starting with 3. So the first term when I put it in is going to be 5 times 3. So the first term is 15. Then I would, since I did 3, now I'm going to use the integer 4, and I'll put 4 in, and I will get 20. This is a series here, so I want to make sure I'm adding in between them. Now when I replace this with a 5, I will get 25, and so on. My last term is when I put the top number in. My last term will be 45. You can see that's adding 5 each time, so that means it is arithmetic. Another way that I can tell if it's arithmetic is by my equation here, or what is called the argument. Since this argument right here, 5n, that is linear, that means it's arithmetic. If it was exponential, then it would be geometric. So I know my first term is 15, my last term is 45. The thing is, I don't know my number of terms to divide it by 2. So there are a couple different things I could do. I could just keep adding all these in until I get all the way up to my last term. Another thing I could do here is think of my t of n equation. So if I wanted to do this, say, in first term form, my first term is 15 plus 5 times n minus 1. My last term is 45, so I put that in here. 45 equals 15 plus 5 n minus 1. Subtract the 15, I get 30 equals 5 times n minus 1. Divide, and I get 6 equals n minus 1, and n equals 7. There are 7 terms. So there are other ways we could do that as well, but now I've discovered there are 7 terms. So now I'm going to go through and calculate. 15 plus 45 is 60 times 7 over 2. I'm going to simplify these two just to make it as easy on me. So I have 30 times 7, and 30 times 7 is 210. So that is the sum of that series. So you could write it as summation from n equals 3 to 9 of 5n equals 210.